right, Mr. Sam's.
Hey, wow, you are fast.
Well, you know, I like to measure myself all the time.
Oh, yeah?
Not like how tall I am, but I like to measure how fast I am.
Ah.
Because, you know, I am fast. Because I always train for these stupid well, they're not stupid, they're great triathlons. So today we're going to talk about measurement and how you can measure things, measure how fast something moves, or like, how am I fast or am I moving at 5 miles an hour, or 6 or 7 or 8 or whatever. So today we're going to talk about measurement and the importance of measurement. Hey, today we're going to talk about measurement.
Yeah.
Yeah, you saw me running fast right there, and which is a certain kind of measurement. And then we're going to talk also about when you can measure that amount
with
like numbers.
Yeah.
And then also we're going to talk about scientific notation. So that's kind of fun. How do you deal with really big numbers, like when I'm going really, really fast?
Yeah.
Yeah. So that's what we're going to talk about today. Okay.
All right, we've got 3 candles in front of us. We're going to do look at some types of measurements on these candles, quantitative and qualitative measurements. So I just told you there are 3 candles. Let's say quantitative measurement because that talks about a quantity.
So it's like a number, isn't it?
It's a number. Quantitative measurements have a number.
That's
on
cool.
Them. So 3 candles. Now I could also take my little ruler here and I could measure this candle. Okay, this candle looks like it's about, I don't know, a little over 10 centimeters. So that's a measurement. I could measure this one. This one is 4 centimeters. So this one, 10 centimeters, 4 centimeters. Those are quantitative.
I would just like call it the tall candle.
Yeah, or the tall candle and the short candle. That's qualitative measurement.
Okay.
Okay, no numerical value assigned to that. Now this one is wider than the other 2.
Fat one.
It's the fat candle. Okay, so that's a qualitative measurement. This is the skinny candle, qualitative measurement. Or I could measure it. This one, it's about 4 centimeters wide, and this one's about 1 centimeter wide. So that's a quantitative measurement. Now, you could use a thermocouple and measure the temperature of the flames, and then I'm not actually going to do it because this isn't a thermocouple. I'm going to pretend, but that would be probably about 500 or 600 degrees Celsius. All the flames could be, so that'd be a quantitative measurement. I could measure a numerical.
So it sounds to me like quantitative have like numbers involved.
Yep. If you have a quantitative measurement, you have a number. Qualitative measurement, you're making a quality assessment about something. We could talk about color. This is kind of a yellow candle versus.
So it's like Mr. Bergman is fast. That would be like what?
That's a qualitative measurement.
Now, Mr. Bergman ran at a 6 minute per mile pace.
Yeah, that's a quantitative measurement.
I see. Got numbers. Yeah.
Yep.
All right.
You know, Mr. Sam's is devilishly handsome. I think that'd be a qualitative measurement. You don't like that one?
Well, you are devilishly handsome. You are a hunk, Mr. Sam's.
Exactly.
Woo!
Oh yeah.
Check out you. My gosh. Look at that. Ooh, yes. Okay.
All right.
You got it? Qualitative, descriptive, quantitative, mathematical.
There it is.
Numerical. Thanks. So, Mr. Sams, when we're measuring things, sometimes the numbers get really, really big. And?
Sometimes, especially in chemistry.
Really, really small.
Yeah.
And you see scientists are tired of writing all
lazy. Chemists are lazy.
They're trying to come up with a better way of writing down numbers. And the way we use is something called scientific notation. So why do we use scientific notation?
That way we don't have to write all those stinking zeros before or after a number.
It has to do with really big numbers or really small numbers.
Yeah, and it also kind of has to do with the accuracy of our measurements, but we'll talk more about that a little bit later.
Yeah. So we want to deal with this concept. So let's kind of talk ourselves through this. So I have some things to measure, or measurements. I've actually, I got off the internet, Wikipedia, I believe. The sun is a very big thing.
The sun.
Now the sun, do you know the sun is a star?
I did.
I bet you did. I hope you did.
Yeah, my son knows that. My son knows the sun is a star.
But why is it so bright compared to like all of the other stars in the sky?
So really, really close to it.
Yeah. But you know the sun is huge. In fact, it is. It looks like 1.392 million kilometers in diameter.
It's big.
So if you draw a line across, this line from here to here is very big.
Yeah.
So, but we, instead of saying 1,392,000 kilometers, we would like to write that in scientific notation.
Yes.
So how do you do that, Mr. Sam?
Well, you take all the numbers that aren't zeros, and you put a decimal between the first and second number.
So that would be between the 1 and the 3.
Right, that's where a decimal point's going to be.
So you'd say 1.392. Now, do I need to use these zeros here?
No, you don't write those down.
Yeah, you wouldn't actually. So, and you'd say times
10 to some power. Now, to figure out the power, you go from where the decimal would have been.
1 to the end, right? 2, 3, 4, 5, 6.
We moved it 6 places, so that's 10 to the 6th power. Okay.
There you go.
Yeah.
That's pretty easy.
It is.
And I bet most of you have seen this before, but it's kind of a review. And if you haven't, now you get to learn it.
Yeah.
Now, there's also like small numbers.
Really small numbers.
So this right here is the diameter of a typical nucleus in an atom. Now, atoms
Okay.
are really, really tiny things.
Really tiny.
And it is 1.6 times 10 to the minus 15th meter.
Oh,
That's
wow.
a small
That
number.
is small. Now that one's in scientific notation.
Yeah, it's in scientific notation, so we
Okay.
need to see if we can write this in sort of what we'd call regular notation, or
Okay.
a regular number.
All right.
Now, so what do I do here?
Well, you've got the 1.6, so we're going to have a 1 and a 6 together.
Yeah.
And we're going to have to move the decimal point 15 spaces to the left.
So we're going to start this number and go 0 point, and I want to start counting. I need
Yep.
to go 15 places,
Right.
sort of. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12,
Uh-oh.
13, 14.
1, 6.
Now the 15th one, this is tricky.
Right.
1, 6 meters.
Right.
Now this right here, the 1 is your 15th place. You don't
Yeah.
have 15 zeros.
Right.
You have 15 places.
Right. So if you want to double check your work, just take your decimal and kind of move it along
Yes.
the zeros, and if it
1,
lands,
2, 3, 4, 5, da, da, da. You should end right here.
it should land between the 1 and the 6.
That'd be
Right.
your 15th place.
Exactly.
Okay.
Now notice that things with a positive exponent are
Yes.
big numbers greater than 1, and things with negative exponents are small numbers, numbers less than 1.
So small, the zeros are in front,
Yep.
and big, the zeros are behind.
end.
So here's another big number. This is the speed of light. So light travels pretty fast. Zoom! Very, very fast.
That was fast.
That was fast.
That was.
Actually, it's faster than that.
Yeah.
Yeah.
Here, let me see the pen.
Oh, okay.
If we, if you take when we draw, where's my pen? There it is. You can put the little speed. Whoosh, whoosh. It means it's going really fast.
Oh, I got
Like on
you.
cartoons.
Yeah, there you go. So
Yeah.
the speed of
It's
light.
the speed lines at the
Okay.
end of something.
This number looks like it
Really
needs to be put in
fast.
scientific notation, Mr. Sam.
It does. It's
So-
too big. I don't like big numbers.
So the decimal goes between the 2
Between the
and 9.
two, yeah, so 2.98.
2.98 times
And then we count how many spots
places.
it went there.
1, 2, 3, 4, 5, 6, 7.
7.
That'd be 7
That's
meters
not
per
right.
second. Isn't it times 10 to the 8th?
It's times 10 to the 8th. I think your number's wrong.
I think this is supposed to be
I
a
think
0.
we're missing a 0 there.
All right, I know it's 10 to the 8th meters per second. So pretend there's an extra 0 there.
Yeah.
Because actually I know that answer. Okay, and then one last one. The mass of a proton.
Ooh.
Oh, that's a
Ew,
nasty number.
That's a lot of zeros.
So one proton. What is a proton anyways?
It's
What the
a
heck is that?
positively charged particle in the middle of an atom.
So yeah, in the middle of an atom
Nucleus.
there's a nucleus, and inside the nucleus is protons and actually neutrons as well. And so if I was to say, well, how big's a neutron, a proton, and this is the size of a proton, or the mass of a proton, I should say. Now, the first non-zero digit's that 1. So between the 1 and the 6 is where my decimal point is.
Yes.
So I'll say 1.673 times 10.
Now it's going to be a negative exponent because this is a small
1,
number.
2, 3, 4, 5, 6, 7, and then 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. That's good, 'cause that's the right answer. Times 10 to the minus 27th kilograms.
You knew that one off the top of your
I
head?
did know that by the top of my head, yeah.
He does that, folks. He'll just pull these numbers out of who knows where, and it's like, where did those come from?
I've seen them for too many years. Okay,
He's
so
old.
I'm old, yes, indeed. Okay, so that is how you would do that. Pretty
All right.
easy, right? Okay.
You know, in my years of teaching Mr. Bergman, there's
Yes.
one thing that students always consistently make mistakes on.
And that would be
Using
their hair color.
their calculator.
Oh, it's the old
I have
calculator.
students who will set up problems perfectly, and then when they go to punch it in the calculator,
They get the wrong answer.
they get
Yeah,
the wrong
you
answer.
know, I have seen that a
and
lot
you
too.
think the calculator would make it easier, but if you don't know how to use it properly,
Yeah,
it's
it'll
going to
mess
lead
you
to
up.
errors. So what we're going to do is we're going to show you how to use your calculator properly to do scientific notation. Now, we're going to show you a way. It might be the same that your math teacher and previous science teachers have told you. It might be different, but our way's better. So we want you
We
to use
definitely
this method.
have the better method.
We definitely have the better method.
So
It's
how
not
to use
the-
your calculator. So what I
Yes.
need you all to do is you need to go get your calculator. Get it out of your backpack, pause the video, wherever. Grab your calculator so that you can follow along as we punch the same buttons that you're going to punch, okay?
Yep.
Everybody push, pause. Get the calculator out.
Yes.
All right, Mr. Sams, tell us about the calculator.
All right, there are a few buttons that you need to use and a few buttons that you need to never ever touch when you're doing scientific notation. All right. The button that is your friend is the EE button. Now on Texas Instrument calculators, it's an EE. If you have a Casio, it says EXP, and some buttons, or some calculators, I'm sorry, has just a capital E. This is not the E with the little exponent X, okay? It is not the second function of the LN. Do not use that one. That's a little lowercase e. You don't want to use that one. It's the capital EE button. On Texas Instruments, it's right above the 7.
And the most common one I see people make a mistake, they will say the times 10 button.
Right. We don't want the times 10.
No,
so
no,
you don't hit
no,
second log.
no.
Because that's times 10. You don't do that one. You don't do second ln, and that's the e to the x. The little e to the x. You don't do that one. Okay? You use second, and then this little guy right here for the EE. And if you have a Casio, it says EXP, and it's usually on the bottom row.
Another thing to note here, folks, there's a difference between the negative button and the subtract button.
Your negative button, on most calculators, it's in parentheses. It's this guy right here.
Some will actually say positive, negative.
Right.
So we have a TI-84 we're working on right now. I don't know what you've got. And the subtract button means to subtract.
Right. So don't do that for a negative exponent. You use the negative button for a negative exponent, this guy right here. Now, one other thing you don't want to use, stay away from the caret. Okay, the caret will not help you with scientific notation. We're going to show you how to put it in the calculator here in just a minute. So don't use the caret, don't hit times, don't hit 10 to the x, and don't hit e to the x. You are going to use the EE button and the EE button only.
Say EE, everyone. EE! Okay, that's what you want to do, the EE button.
Give me an example.
All right, let's say that I have 5.3 times 10 to the 8th meters.
All right, 5.3 times 10 to the 8th meters. Here's how I put that in my calculator.
Everybody follow along.
5.3. Now, times 10 to the. Here's what you're going to do. You're going to go second EE. It means times 10 to the. And then 8. 5.3, second EE, 8. Those are the keystrokes that you put. Let me do that again. 5.3, second EE, 8. That means 5.3 times 10 to the 8th power. Do not do this. Let me show you what not to do. Do not go 5.3 times 10 caret 8. Now, that will work occasionally. That starts to be problematic when you start to multiply and divide and add and subtract numbers. Typically dividing, right. If you're a parentheses guru, that will work. If you do not use them properly, it won't work, so don't do it.
Just
use the EE button. EE button.
Okay. So now,
right,
one thing we should, let's do one
Let's do
here.
one with a negative.
Oh, okay. All right.
Give me a negative one.
So let's do a negative one. Let's say that the diameter of a nucleus is 6.23 times 10 to the negative 16th meters.
Okay, 6.23. 6.23 times 10 to the, which is second EE. Okay? Now, when I punch that in my calculator, I always say times 10 to the in my head. When I hit the second EE, I always go times 10 to the, in my head, negative 16.
Got that, guys? Now, let's see what these numbers would look like on your screen.
When they show up on the screen.
When they show up on the screen. All right. Okay, we're back. Now, I want to talk about making sure you know what the buttons are. Not the buttons, but what it should look like on your calculator, because it's kind of weird, isn't it, Mr. Sanders?
Yeah, it is a little one.
So let's say I've got 5.01 times 10 to the minus 13th meters.
Let me put that in. So 5.01.
So now what, guys, you see on the side here is you do not see, you just see the screen. So what,
5.01, then second EE, negative 13. 5.01, and on your screen it has an E.
Yes.
A capital E, negative 13.
Yeah.
That means 5.01 times 10 to the negative 13. Here's what I don't want to see. Do not, under any circumstances, put 5.01 times second EE, negative 13.
Oh, yeah.
Okay, because if you do, when you press enter,
it'll be 10 times too big.
You get a wrong number.
Oh, it just screws everything up.
So don't do that.
Yeah. So watch that. You got to watch that. You need, and then something that's kind of weird, guys, is that you're going to push an EE button, And at least on a TI graphing calculator, it's going to just produce one E there. That's
Yeah.
kind of odd, isn't it?
Yeah.
But that's just it. The E really means,
Times 10 to
means
the-
times 10 to the power of whatever. In our case, negative 13th. That's what it means. Do not do the times 10 thing.
Right. Don't hit
Screws you
times.
up.
Don't hit 10.
No.
Yeah.
All right, let's do one more.
Okay,
Make sure
let's
you
do
can
one
see
more, and
this.
I'll show you another
Actually,
comment.
let's do a little calculation. How about
Okay.
that, Mr. Sams? So let's say I've got 6.02 times 10 to the 23rd, and I want to divide that by 8.01 times 10 to the negative 16th. I don't know why I would do that, but
Yeah, I don't know either. All right, so 6.02 second EE 23. That means times 10 to the 23. Okay, divided by 8.01 second EE, which means times 10 to the negative 16. And I hit enter, and I get some big numbers. 7.52 times 10 to the 38th power.
So it says 7.52 E
E38.
38.
Yeah, there's a whole bunch of stuff, and then E38. Don't forget to look for that E38 at the end. Now, let me show you something.
So how would I write that, though? I would write that in my paper as
Right.
7.52 times 10 to the 38.
And actually, if you leave the E38, that's perfectly acceptable.
Yeah.
So that's fine too. Now, let me show
These
you
are the
something.
same number here.
If
right?
you do not use the E button and you are not good at using parentheses, let me show you what happens on this particular
Oh,
problem.
Mr. Sam's
If
gonna make a
you do it
mistake.
wrongly, 6.02. Now I'm going to hit the times button, and then 10, and then that caret, 23. Okay, that means 6.02 times 10 to the 23rd. It does, but now I hit divided by
Yeah.
8.01 times 10 caret negative 16. That
You're
means
gonna get a
8.01 times 10
totally
to the
jacked
negative
up
16.
number, Mr. Sam.
But since I didn't use my parentheses,
You're going to get like,
I got 7515605.
which is not right.
That is not the same thing as 6.52 times 10 to the 38th power.
Yeah.
That's 7.52 times 10 to the 1, 2,
I think the moral of the story,
that's
guys-
the 6th power. Don't use the 10, use the EE.
Use the E
Yes,
button.
Use the E.
Now, in my calculator, the one that we're working with here, the E is the second function. Some
Yes.
calculators, it's the first
Yeah, on the
function.
Casio, it just has an EXP, and it's in the bottom
Keep,
row.
yeah, you just got to find it.
Yeah, just
on
find
your
it.
calculator.
Ask your teacher. They know where it is. They'll
right.
tell you.
So the key on this, Mr. Sams, would be what?
E.
Got to use the EE button. And
E,
if you stop
E.
using the EE button, we will be very mad at you. Get the-
You know what's really funny? People will show me, Mr. Sams, I'm not getting the right answer, and I say, okay, punch it in your calculator for me, and they don't use the EE button. You know what I do?
You laugh.
I laugh,
I don't know what else you do.
and I laugh. I usually say, silly, silly child, have I not taught you to use the EE button?
And actually, I usually just impatient and say, why don't we use the EE button? But Mr. Sams is meaner than me.
I'm evil. I will laugh at you and make you feel like a silly person.
No, he won't.
No,
That's
I
not
won't.
true.
But
seriously,
use the EE button.
Use the EE button. All right, nice job.